So here now we are going to on two-dimensional problems of elasticity. So the problem is calculate the element stresses for the element shown in figure. Okay, and for a plane stress condition. Okay, this is very important, whether it is an plane stress condition or plane strain condition. Okay, sometimes both may be included in the problems. So when nodal displacements are as given below. So this is a question. Okay, so it's an two-dimensional problem for elasticity. So having you need to calculate the stresses. Okay, sigma you have to calculate, and for a plane stress condition, this is very important. For plane stress condition, which condition is given, that is most important, because the formula will be different for plane stress and plane strain. And now the figure is, you have to draw the figure. So there is an okay, so like this, and here are, this is q1, this is q2, and here at 2 q3, this one is q4 as the displacement. Okay, and at here q5, this is q6. Okay, and at each point there are some coordinates, I is equal to, or you can say 1, that is 0 0 here, and here for j, or you can say 2 250 0. Say this is node 1, node 2, node 3, then it will be clear. Now here 250 250. So these are the coordinates x y. Okay, and this is a reference line as x and y. So what are the displacements are given in this question? Displacement, like you have q1 to q6, q1 and q2, that is 0. Okay, and q3 q4, q3 is 0.001, and q4 as 0.002, and q5 minus 0.003, q6 0.002, and Young's modulus value is equal to 200 gigapascal. Okay, and Poisson's ratio as given as 0.25, thickness P is equal to 20 millimeter, and thermal coefficient 2 into 10 power of minus 6 per degree Celsius, and change in temperature as 50 degree Celsius. So these are the given value which is given in the question. Now for the plane stress condition, okay, so here x1 y1, anyhow the coordinates which you already know, this is x1, this is y1, this is x2, this is y2, and the third one will be x3 y3, this one will be x3 y3, like that. Okay, x3, this is y3, these are the coordinates. Okay, now what is the B matrix here? B matrix, that is strain displacement matrix, strain displacement matrix, where B is equal to 1 by 2a, okay, 1 by 2 into a in the matrix y23 0, y31 0, y12 0. Next in the second row 0, x32 0, x13 0, x21. Third row x32, y23, x13, y31, x21, y21. So this is the matrix. So here just for the example, 21 means y23 means it is a y2 minus y3. Like that you have to calculate for the rest of the values. So for example here y2 minus y3. Now just look at the y2 minus y3. y2 is 0 and y3 is 250. So 0 minus 250 you are getting 50. Right? The value will be minus 250. Okay, now coming to 1 by 2a. So make it 1 by 2a value. Okay, so first to 2a. So 2a means the area for the ant. So where first we will calculate what is area here. Okay, so area is equal to again 1 by 2. Okay, so 1 by 2 and these two both will cancel. So if we calculate the area, then that is equal to 2a. Okay, so area is equal to 2a. Now, so this is an determinant of 1 x1 y1, 1 x2 y2, 1 x3 y3. So here 1 x1 value is 0, y1 value also 0. Similarly, there is a 1 x2 value is 250, y2 value is 0. 1 x3 value is 250, y3 is also 250. Now we make the determinant. So 1 in the bracket 250 into 250, it is 6 lakhs 25, sorry, 62,500. Okay, minus 250 into 0, it will be 0. So again 0 0, so both will get 0 0 here, right? So it is 625 into 10 power of 2. So millimeter square, area will be millimeter square. So finally where 2a is equal to this answer, right? Yeah. Now what we'll do, we'll substitute strain displacement matrix where b is equal to 1 by 2a. 2a is 625 into 10 power of 2. Again we have matrix. So as I written the matrix here, this is a matrix y23 y31. So you have to make this y2 minus y3, then you are getting first row first column, then again third row third column, like that you have to make it, which I already practiced here, that is there with me. I just substitute the value. So y23, okay, y23 we got minus 250. Next 0 250 0 0 0 0 0 0 minus 250 0 250. For third row third column, minus 250 minus 250 250 250 0. So this is strain displacement matrix. Later we'll go for calculating the D matrix, that is material property matrix. So this will be a problem and also plane strain problem. Okay, the formula is different here. It's E by 1 minus V square in the matrix there will be 1 v 0 v1 0, so 0 0 1 minus v by 2 strain displacement matrix, D matrix. Okay, now we have the Young's and also Poisson's ratio. So Young's modulus value is given 200 gigapascal. Okay, so you need to convert into millimeter because all values you are taking in millimeter. So it is 200 gigapascal. It means 10 power of 3 converted into megapascal. Okay, divided by 1 minus v. V is a Poisson's ratio. That value is 0.25 squared. Again in the matrix 1.250, 0.2510, so 0 0 1 minus 0.25 by 2, so 1 minus 0.25 2 we got as 0.375, 375 we obtained from this calculation. Okay, so now we'll make the thermal strain vector. So now the thermal strain vector, it means a load vector, epsilon x, that is equal to alpha into change in temperature. So alpha is given as 2 into 10 power of minus 6 into change in temperature is 50. We got alpha into 10, so 10 100 into 10 power. So 10 power of 2 into 10 power of minus 6. So we are getting 10 power of 4, 10 power of minus 4. Okay, so that is for epsilon x. Similarly for epsilon y also 10 power of minus 4. Okay, so now what is the thermal here? We make epsilon naught, this is equal to epsilon x epsilon y 0. So if you take 10 power of minus 4 outside, then in the bracket there will be 1 1 0, this is a load vector. Okay, similarly stress element, you need to find the stress equal to, that is D matrix, the bracket, so epsilon minus epsilon naught. Okay, so this epsilon is equal to what? B into Q. So D B Q becomes dBq for the first one minus D into epsilon naught. So now you just substitute what is D, what is B and Q. Okay, anyhow for the Q, which is in the question, but anyhow I will write. Q is the displacement vector, that is Q1, Q2, Q3, Q4, Q6. So Q1, Q2 is 0 0, Q3, Q4 as 0.001, 0.002 minus 0.003 and 0.002, in the transpose we are written, but you have to make it vertical right there. Okay, now make the multiplication with all these three, again minus of D into epsilon naught, which you have just now calculated. After whatever the calculation you have done, make the subtraction. So we are getting the final answer. I will write here because it will take more time. So we have to, after subtraction we are getting minus 25.8093. okay, and another value is sigma y value is 26.449, and the last one minus 0.6400. These are the stresses. Okay, sigma x is one, in megapascal it should be. Okay, and this is sigma y, same, this is sigma z. These are the stresses in the element. So thank you for watching.